Hi, in this video, we're going to learn about inverse functions. So how do you find an inverse function? Well, the first thing you want to do is make sure that the function you are given is one-to-one. If it is not one-to-one and it fails what's called the horizontal line test, then there is no inverse, all right? So make sure it's one-to-one. Every x has one y and every y has one x. Okay, now once you have determined that, you're going to replace your f of x with y, swap the x and y, then you're going to solve for y. Okay, I'm going to repeat that again. You're going to rewrite it, so instead of f of x, you're going to write y equals. Then you're going to switch the x and the y in their spots. So everywhere there was an x, you now have a y. Everywhere where there was a y, you now have an x. And now you're going to solve for the new y where it is now. And once you do that, you can name it f inverse of x. That f with the little -1, you don't read it f to the -1. It's f inverse of x. At the end of everything, I highly recommend checking your answer. If you did indeed find the inverse correctly, then f of f inverse of x and f inverse of f of x should both equal x. So let's walk through an example. Let's say I give you the function f of x equals 2x minus 3. Now this is a linear function that has a positive slope that looks very much like this, and you can see that this is one-to-one. Every x is exactly one y, and every y has exactly one x. You can test this using the graph by doing what's called the horizontal line test. That means if you could draw a horizontal line anywhere, it should pass through one point at most. And you can see if you tested that out, there's only 1 point everywhere you go. So it is one-to-one. There is an inverse. We can continue. So let's take a look at this. We're going to replace f of x with y. So now we have y equals 2x minus 3. Then we're going to swap the x and y. So now it's x equals 2y minus 3. Now that we have this format of the equation, we're going to solve for y. To do that, I'm going to start by adding 3 on both sides, and then I just need to divide by 2. I do like writing as y equals, so I will flip the equation and make it y equals x plus 3 over 2. Now that I have my y isolated, I'm going to replace it with f inverse of x. Again, we like that function notation. So now we can say our inverse function is x plus 3 all over 2. Now, we do want to check this whenever possible. So given that f of x is 2x minus 3 and f inverse of x is x plus 3 over 2, we're going to do our 2 checks. The first one is f of f inverse of x should equal x. So we're going to plug x plus 3 over 2 in for x in our first function. When we do that, we can simplify. Now you'll notice that 2 times x plus 3 over 2, the 2's are going to cancel and leave me with x plus 3. And I carry down my minus 3. Then 3 minus 3 cancels, and I'm left with x. So indeed, this composite function comes out to x. Now remember though, you have to check both of the directions. So we're also going to check f inverse of f of x. So we'll plug 2x minus 3 into f inverse of x. That gives me 2x minus 3 plus 3 all over 2. When I combine in the numerator, minus 3 and plus 3, I get nothing. So I have 2x over 2. And when I do that, my 2's cancel and I'm left with x. So we have confirmed that it works in both directions. So we did accurately find our inverse. I do want to show you one other example, and this one is f of x equals negative x squared plus 2x plus 3. Now this is a quadratic, which means it is not one-to-one and it has no inverse. And when you look at the graph, you can see that I could draw horizontal lines in many places and it go through more than 1 point. All right, so remember the horizontal line test is a great visual way to confirm that. Now again, because it has no inverse, I don't do any of the steps I did with the other practice problem because it's not possible to find an inverse. Now, you can restrict the domain. Maybe you slice this parabola in half and you only work with one side or the other, but that would be a requirement in order to work with this and make it one-to-one. So unless it happens, no inverse, I get to stop this problem. All right, that is how you work with inverse functions.